Today we are solving radical equations. We will be doing this both algebraically and graphically. To solve them algebraically, you want to first isolate the radical on one side of the equation. So that means you'll use inverse operations to get that radical by itself. So that means you want to look outside of the radical and undo anything that's with that. And then to eliminate the radical, we raise each side of the equation to a power equal to the index. So square root, square power, cancel each other out. Cube root, cube power, cancel each other out. And then your resulting polynomial equation, you will solve that. If it's linear, you solve it with inverse operations. If it's quadratic, you would solve it with quadratic formula. So when we look at example 1, outside of the radical sign, we are adding 2. The inverse operation of adding is subtracting. So to isolate the radical, we're going to subtract 2 from both sides. And then to eliminate the square root, we take both sides to the square power. So we get 3x minus 5 equals 16. Next, we would add 5 to both sides and then divide by 3. So we get x equals 7. For example 2, so remember 1/3 power is the same as a third root, so we'll treat it the same. You want to start outside of the parentheses, so we do inverse operations in reverse order of operations. So I'm going to add 9 to both sides first. Then there's multiplication outside of the parentheses, so I'm going to divide both sides by 4. And then the inverse operation of 1/3 power would be the third power. So notice that these are reciprocal powers, 1/3 and 3, so those will cancel each other out. When you take a power to a power, you multiply the exponent, so 1/3 times 3 gives us 1. And then to simplify that, we would subtract 6 from both sides and then divide by 2. Example 3 is a little bit different because we have a radical on both sides. So as far as isolating the radical, if we were to subtract 3 to isolate this radical, then the radical on the left is not isolated. So since the one side has the radical isolated, we are going to square both sides, so that will eliminate the square root on the left. On the right-hand side, however, we are squaring a binomial, so the steps for squaring a binomial are square the first term, multiply the two terms together, then double that product, and then square the last term. So squaring 3 gives us 9. If I multiply these together, we'd get -3 square root of x, double that, -6 root x, and squaring the last term gives us x. So now we are down to 1 radical. So to isolate that radical, we're going to subtract x from both sides and subtract 9. Our radical is multiplied by -6, so I'm going to divide by -6 and then take both sides to the reciprocal power, or the inverse operation. Inverse of square root is square power. -2 squared gives us 4, and then square root and square power cancel each other out. So we got x equals 4. Now we're going to substitute that back into the original equation and see if we get a true statement. So replaced both x's with 4. On the left-hand side, we have to do what's under the radical sign first. 4 plus 21 is 25. And then on the right-hand side, the square root of 4 is 2. The square root of 25 is 5, and 3 minus 2 is 1. So we do not get a true statement because 5 does not equal 1. So 4 is an extraneous solution. There are no real solutions to this equation. For number 4, we want to isolate what's in parentheses. So you start outside the parentheses first. So first we're going to subtract 8 from both sides. And then the parentheses, we have multiplication by 2/3. To undo that, we'll multiply by the reciprocal, 3/2. And then to get rid of the 1/6 power, we do the 6th power on both sides. So 1/6 times 6 is 1. And then to isolate x, we will subtract 14 from both sides and then divide by 11. We can solve radical equations by graphing. So the next examples, I'm going to show you how I do that on my graphing calculator. There are two ways to do that. One is you can find a related function. So you want to get your equation equal to 0, and then you replace 0 with a y, and then you can graph that by finding the zeros. The second option is to use a system of equations, and that would be where we let y1 equal the left-hand side of your equation and y2 equal the right-hand side, and then we find where they intersect. So I will show you both of those. So this first one, we're going to graph this by finding a related function. So we want to get it equal to 0, so we're going to subtract 9. And then from here, I'm going to show you on my graphing calculator how to do that. So we're going to press y equals, and then we'll enter in our related function 2, and then to get the cube root, we press math and 4, cube root of 3x minus 4, and then the plus 1 is outside of the radical sign, so I have to arrow to the right before I press plus 1. Okay, and then when we look at the table, so remember we're looking for the 0. When is y 0? First, I'm just looking where it changes from negative to positive. So for y values to change from negative to positive, it must cross the x-axis. So somewhere between 1 and 2 is my answer. So now I'm going to look at the graph and find this x-intercept right there. So I'm going to press second trace 2. And then for left bound, I'm left of that x-intercept, so I press enter. Then move to the right till you're beyond that and press enter, and then get your cursor as close to that x-intercept as possible for guess and press enter. And the answer is x equals 1.29 when we round to the nearest hundredth, which is what we thought from our table that the answer would be between 1 and 2. For the next example, we are going to solve that using a system of equations. So our original equation is square root of x plus 6 minus 5 equals negative square root of 2x plus 1. So we're going to let y1 equal the left-hand side of the equation and y2 equal the right-hand side of the equation. So I'm going to go back to y equals. I'm going to clear that out, and I'm going to type in the square root. To get the square root, we press second x squared. Make sure you arrow out of the radical sign before you press minus 5. And then in y2, we're going to type in what we had on the right-hand side of our equation. Arrow to the right, that plus 1 was not under the radical sign. And now when I press graph, I'm looking at where do those intersect. So I'm going to use the intersect feature by pressing second trace 5. And then first curve is whatever your cursor will show up on whatever you entered into y1. And then second curve is what we entered in y2. And then for guess, I'm going to move my cursor closer to that point of intersection and press enter. And that gives us, if I round to the nearest hundredth, 4.02. Example 7, the square of the time it takes a planet to orbit the sun, t, is equal to the cube of the planet's mean distance from the sun, a. The relationship can also be written as t equals the square root of a cubed, where t is measured in years and a is measured in astronomical units. If it takes Mars 1.88 years to orbit the sun, use a graphing calculator to find the mean distance from Mars to the sun. So I substituted 1.88 in for t, for time, and then to get rid of the square root, I take the square power of both sides, so I squared both sides, and then I took the cube root of both sides. So the mean distance from Mars to the Sun is about 1.5233 AU. We can use a graphing calculator to confirm this. So back to my graphing calculator. So I'm going to enter in on 1.88 for y1. I'll clear out this for us. And then on the y2, I'll enter what we had on the right-hand side, so square root of x cubed. All right, and then I'm going to look for where they intersect, so I'm going to press second trace 5. And we're getting 1.523. So it's the same thing we got when we solved it algebraically. So that's a good sign. Thank you for watching.